Welcome back, Matrix. Now, we're still learning more right here on Learnextra, and for now, we are taking you through some of the questions that you have on your prelim, and also to help you on your prelim questions. I'm joined now by Edzai. How are you, sir?
I'm all right, Avram.
Are you ready to learn, since it's a Saturday?
Yeah, I hope mindsetters out there are ready to learn, because remember, maths is to the mind what love is to the heart.
I like that. I like that. And talking about that, I shared a quote on the Facebook page saying that learning is a gift, even when pain is your own teacher. Because, you know, some of us are having those teachers. But here on Mindset, we're having the best teachers ever. That's why Mr. Edzai is going to be taking us through some of the questions. Take it over, sir.
Sure, thank you. Okay, Mindsetters, today we're going to be looking at a question that was adapted from the Eastern Cape. So you find that it was from the September 2012 paper 2, right? It was the prelim exams. Now, let's look at what we are required to do, right? The question says, simplify without using a calculator. It's important, extremely important for you to understand the question before attempting to do anything. First of all, understand what you are required to do. So in this case, to simplify, what is it? What does it mean? It means you have to write this very same expression, right, in a simplified form. They're not saying solve anything. They're not saying find the value of anything, but they are saying simplify. So write the same expression, but in a simplified manner. And another key aspect is that I know that with exam pressure, you might not see that it says without, right? So it's important for you to understand without using a calculator. Now, let's get on to the problem. Right. We've got tan 360 minus x, right? I think there was just a glitch here because there's supposed to be brackets over there. So it's tan of 360 degrees minus x multiplied by, that dot, multiplied by cos x minus 90 degrees, of which we're saying the brackets imply that the cos, we're saying cos of the angle x minus 90 degrees, right? Plus the cos of 540 degrees minus x. So that is our numerator, and everything is divided by tan of x. Tan of x. So now, before we start simplifying this, let me just take you back so that at least you have some background information on how, what information you can actually use, right? So now, the first thing is we see that there's a tan, right? We see that there's a tan. So the definition of tan is tan x is equal to cos x, sin x over cos x. Okay, that's a common mistake, right? Sin x over cos x. So that's the first fundamental thing that you have to know, right? I hope we're all together there. And then we see now that our angles are not just singular angles, but they are compounded. You see that there's a subtraction and addition, right? Subtraction of angles, yeah. So we need to understand the mathematics of trigonometric quadrants, okay? So I'm just going to draw you a circle and illustrate what the quadrants are all about, right? Remember, we measure our degrees in an anti-clockwise manner. So we start at 0 here, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 shares with 0 degrees. And we can continue, right? Because I see that in our question we've got 540 degrees. So I'm just going to continue measuring that. So 360, we're going to have our 450 degrees here, and then 540 degrees there. So I hope you understand what I mean there. Then, the second thing that you have to know about the quadrants is that sine, cos, and tan are all positive in the first quadrant. That is, between 0 and 90 degrees, you have your sine, cos, and tan being positive. Then, in the second quadrant, do you still remember, Abraham, from your high school?
Well, unfortunately, I don't remember.
Okay, all right. No, it's fine. Matrix, remember. Okay, so in the second quadrant, we have sine being positive, right? And then third quadrant, tan, and we have cos. Is that it now, right? That's it. Now, just moving down, we are going to now take down our problem piece by piece, right? Until we get to the solution. Remember, don't rush to the answer. Do it step by step so that you get all the marks that are possible, okay? Right. Now, the first thing that we're going to look at, I'm going to look at it individually, tan of 360 minus x, okay? Right. Now, tan of 360 degrees minus x, right? We're saying in which quadrant do we get this this expression, right? In which quadrant? Now, let's go back to our circle, right? That's illustrating the quadrants. Now, 360 is here. If you subtract, you'll be going in the clockwise direction. So if you subtract x, of which we are working on the assumption that x is a value that is not more than 90 degrees, right? So it means that it will lie in the fourth quadrant. Now, in the fourth quadrant, you ask yourself, what is tan? What is the value of tan? Is it positive or is it negative in the fourth quadrant? When you look at it, you will find that only cos is positive, right? So that means that our tan is going to be negative in the fourth quadrant, right? So already we know that we can express tan 360, right, minus x as negative, right? So it's going to be, another way of looking at it, right, is that when you move in the clockwise direction, right, your angles are negative. You understand? Your angles are negative. So you can look at it in this way, saying, my starting point is here at 0, right? And if I move x degrees clockwise, I am going to end up in the fourth quadrant. So in other words, the value of this angle is negative x. So we can rewrite this as tan of negative x, right? So we have changed the format of tan in this case, right, where the 360 now has been converted to a negative x, right? Let's go on to the next one. The next one in our problem is cos x minus 90 degrees. Cos x minus 90 degrees. Right. Let's just write that down. Right. Cos x minus 90 degrees. Right. Cos x minus 90 degrees. Now let's look at that again. Right. There's our quadrant. This is our quadrant diagram. Just going to annotate it in blue so that you remember what it is. Right? Now we're saying we've got cos x minus 90 degrees, right? As we said here, right? Now what do we do? What do we do, right? We've got a cos that is between x, sorry, you know what? Just before I continue, can you just check on Facebook what's happening so that we can get the results? Yes, please.
I'll do that. The mindsetters certainly are enjoying the show. And mindsetters, I'm urging you, if you're having any questions based on this question, make sure that you post it on Facebook. Just like other mindsetters saying, you know what, this is so easy, we can even get a distinction, such as Nom Sanko Sukumbi saying, I'm definitely coming out with my distinction. So if you're still confused, go over Facebook and let us know what are your questions.
Right. Okay, so now, just to continue, remember, we have cos x minus 90. What I'm going to do now is that I'm going to play around with the relationships that cos and sine have. Because remember, sine x, right, it's the same as saying cos of x minus 90 degrees. So if two angles are complementary, right, they're going to have this type of relationship where the sine of x would be equal to the cos of x minus, sorry, it's the other way around, 90 minus x, right? 90 degrees minus x, like that. And also, we can have cos of x is equal to sine of 90 degrees minus x. So, with this knowledge, right, I am going to try and use it, right, to come up with a simplified version of this, right? Now, I also know that negative 1 times x minus 90 degrees is going to give me 90 minus x, right? It's going to give me that. So first of all, I'm going to apply that negative multiplication so that I can have it in this form, right? Because I want it in a way that can help me simplify this, right? Now here I'm going to rewrite this expression and say cos, all right, negative 1 x minus 90, right, like that. So this would give me cos, the negative is going to be out there, negative cos x minus 90 degrees, which is equal to, but remember, cos is a symmetric, right? So negative cos x will be equal to cos x. Remember that, okay? That's why I'm able to use the negative, right? So now, once I've got this, so negative cos will be equal to positive cos. So this is the negative, positive, same thing, right? Cos 90 minus x, like that. Okay, that's what I have. Cos 90 minus x. Just to clarify that, I am using the fact that cos is symmetric. What do I mean by symmetric? If you have to draw the cos graph, right? At the origin here, you'll find that cos of negative 90, right? 90 degrees is the same as cos of 90 degrees. So that's the symmetry that I'm talking about. So I can utilize the fact that negative cos x would be equal to cos of negative x, right? Cos of negative x. So that's the relationship that I'm using here, right? To say cos of negative x minus 90 would be equal to negative cos of 90 degrees, x, 90 minus x, sorry. This is 90 minus x, right? Like that. So we have a situation now where we can say cos of 90 degrees minus x. Let's go back to our rules, right? Where are they? They're here. Remember, it says that cos of 90 degrees minus x would be sine x. So now I know I can replace this with sine x. Okay. So I've done the second one. Now let's go to the next one, which is cos 540 minus x. Okay, I'm still using my circle here, right? 540 is there at the boundary of the second quadrant, right? Now we've got 540 and we're subtracting x. Remember, x is less than 90 degrees. So it's going to fall within the second quadrant. And in the second quadrant, what is cos positive or negative? From our rules, it tells us that only sine is positive. Thus, cos will be negative. So we can reduce this to cos minus x, right? Cos minus x. So cos 540 degrees minus x can be reduced to cos of negative x. But remember, right? Remember that, minus negative, oh man, right? Minus cos x, right? Because it's negative. So now we've got our numerator. We can now go back to our problem and rewrite the problem, right? Rewrite the problem. I'm just going to put it on the side here. Remember, tan 360 minus x, we got tan minus x, right? So I'm going to write it like that. So this is equal to tan minus x, right? Multiplied by cos of x minus 90. We found that the answer would be sine x. Remember? Sine x. So we're going to write that down again, right? Sine x. And then cos of 540 minus x, right here. 540 minus x would be negative cos x, right? Everything is all over tan x. Tan x is our denominator, our universal denominator, right? Now, let's take this simplified version and simplify it even further because we still have more relationships that we can use. So just a second, right. So it's tan of negative x, right, multiplied by sine x minus cos x over tan x. Right. That's what we have right now. Next step is to actually now simplify tan, right? Tan. Because remember, tan can be written as sine x over cos x. Right. Now, let's do that. Okay. Right. So we're going to change this now to negative sine x over cos x. The reason why I put the negative out is because there's a relationship that says tan negative x is equal to negative tan x. Okay, so that relationship is always there. So I've taken the negative out. That's why it's there. So your tan is that one. Can you see? So it's negative tan x multiplied by sine x minus cos x. Everything over our denominator, which is tan x, but I'm going to write it as sine x over cos x. Right. So what I've done now is that I have expressed the compound angles, right, as singular angles, and I've also expressed tan x as sine x over cos x. Next, the next step would be to now simplify this whole expression, right, even further. Okay, so remember this is sine over 1, cos over 1, right? Now, negative sine times sine, it will give us negative sine squared, right? Negative sine squared. That's what we're going to get by multiplying these two, right? We'll get a negative sine squared, and our denominator is cos x, right? Cos x. And we've got a negative sign there, subtraction sign here. We edit, right? Cos x over 1. And remember, we've got a universal denominator, which is sine x over cos x. Right. I hope my setters, you're still with me. We are simplifying this. We're taking it slowly, step by step, but this is something that, because of the constraints of time in an exam, you can actually do even quicker. Okay, so but we're doing it so that you understand the background information step by step, right? Now, the next step is for us now to express the numerator as one fraction, right? So we're going to subtract the 2. So our common denominator in this case is cos x. So I'll write that down, cos x. And my numerator, if you do the cross multiplication, it's going to be minus sine squared x, the negative sign here, minus cos squared x. Right. Those of you who are intuitive are already seeing an identity of some sort there, right? But don't forget that this is only the numerator. We've got a universal denominator, which is sine x over cos x. Right. Now, once we've done that, we can now, remember when you're dividing fractions, right? You invert the denominator and multiply. So this is our denominator, and the one in brackets is our numerator. So what I'm going to do now is I'm going to make use of our identity. Cos squared x plus sine squared x is always equal to 1. That's an identity, right? So it means that if I factor out the negatives, right? If I'm going to have a situation where it's now, our numerator is going to be negative cos squared x plus sine squared x, right? Like that. But remember, this inside the bracket is equal to 1, so the numerator can actually be expressed as negative 1. So I am going to now rewrite it for your convenience. This is -1, right? -1. Let me just extend my page, right? And then don't forget about this denominator. It's cos x. And then we're going to now multiply by our denominator, okay, which is now cos x over sine x after inverting. Right. Now, I think we've actually reached our answer. We just have to finish off with the factorization, with the crossing out of equal terms. So in this case, cos x and cos x cancel out, and our answer will be -1 over sine x. So that's our final answer, and I hope that you've been following. Let me just do a high-level overview of what I've done here so that at least you might remember the steps, right? So here's what we did. Our original question was tan 360 degrees minus x, right? Oops. Right. Tan 360 degrees minus x multiplied by cos x minus 90. So remember, the brackets there, right? Plus cos of 540 minus x, right? Which is also in brackets. Right. So what we did, we expressed these three as singular, right? As singular values in terms of x, right? We did that, and then we went on to simplify tan and expressed it in terms of sine and cos, which we did successfully, right? Then after that, we simplified by crossing out like terms and also using our identity, sine squared plus cos squared equal to 1, and we got our answer. So I hope that this was helpful to you, and I hope that you are now at the peak of your preparations for the matric exams, because this is the time when you determine your future, and I know you can. Even if you have been struggling, you still have those few days to actually change your fortune. Thank you.
I like that. That's so inspirational. And also